All right, here we go. Come on, computer. There we are. Section 6.5. Title of this section is called Graph Square Root and Cube Root Functions. So two different functions we are going to graph. I'm going to try to preview today at the end of class. We are going to graph the square root of x. That's the square root function. And we're at the same time two functions for the price of one. We're also doing the third root. And I think the book thinks that if you can do the square root and the third root, then you can really do the fourth root and the fifth root, or the sixth root and the seventh root, and so on. So a radical function is, with this square root symbol, this radical symbol, I should say. This, again, square root. You could put a 2 here if you want, but typically we don't need to. So I thought, one slide ahead of you. The parent functions of the square root and the cube root function. So the parent graph is always the most basic form of the graph, and then we'll mess with it. So we're looking at the domain for the square root of x greater than 0 and the range y greater than 0. Now I'll show you the graph, the parent graphs on the next. I'm going to show them right now. So here is the parent graph for y equal the square root of x. And so key ingredients here are that when x is 0, y is 0, right? Square root of 0 is 0. And then notice when x is 1, y is 1. The square root of 1 is 1. You really don't want to plot the square root of 2 because we don't really know what it's at. Square root of 3, not really sure, but the square root of 4 is 2. So typically for me, if I'm graphing the square root of x, I have 3 points, and then I kind of know what this general shape is. It kind of, I don't know what you'd call this. You can see if you tilt your head to the right, like I am, that it's half of a parabola. That's that shape, that parabolic shape on its side. Domain, huge restriction for the domain, right? We can see clearly that x is greater than and equal to 0. And for the range, hopefully you can see quite clearly that y is greater than and only equal to 0. So this function never is in the negative for y or the negative for x. And then the other one was the parent graph for the cube root function. So this cube root function. And notice the domain and range here, all real numbers. How the heck does that work? Well, here's the graph of x. Sorry, this is the graph of the third root of x. And notice if you're plotting points, we go through the origin, right? The third root of 0 is 0. Notice the third root of 1 is 1. And the third root of negative 1 is negative 1, right? Negative 1 times negative 1 times negative 1 is still negative 1. And then a lot of times we won't have room to plot it, but the next easy point is the third root of 8, which would be 2. And the third root of negative 8 is negative 2. But a lot of times that's not on your screen. So you hopefully can kind of memorize this parent graph shape. It's kind of a neat, I don't know what you'd call this. Looks, again, if you turn your head to the side, that is half a parabola and then another half, but kind of thrown off. And I actually can't even call it a parabola because it's the third root. It would be like, it's a third order polynomial inversed. Anyways, let's talk about the domain. Hopefully you're seeing, hey, values of positive x values, 0 works, negative. So this is all real numbers. And then for the range, you can see that you're also in positive y values. Your y is equal to 0. Y is also negative. So again, we're all real numbers. Nice job. So here we go. We're going to start graphing. So notice we're going to go in little baby steps, if you will. They're going to say, hey, what happens to the parent graph when I put a 2 in front? And from your quadratic and from the absolute value functions, you should say, hey, that's a vertical shifting. You're supposed to, or stretching, I should say. You're going to accelerate the y values. And so I'm going to go a little bit quicker here. You can see the parent graph, when you went over 1, you went up 1, right? Square root of 1 is 1. But now you're going to multiply that by 2. So you're pulling the graph up. And notice here, the square root of 4 would have given you 2, and that now is going to be at 4. So you really kind of think of this as a vertical stretch. You pull it up, and that's based on that 2. I don't think there was anything else down here. Yeah, they use the word stretch just like us. The domain and range, by the way, do not change because of that. That's interesting. So now we're going to apply that to the cube root, right? Here's the parent graph. What happens if we put a negative? And you again are sitting back saying, hey, no big deal. That flips the graph. You know, we've done that with parabolas. We did that with the absolute value. The 1/2, ooh, that's going to be a vertical shrinking, right? Your y values are going to be halved. So here, sorry, the graph's a bit confusing, but you can see here this is the parent graph. Maybe I'll make this a dashed blue. That's the original parent graph that I showed you earlier. So the negative is going to flip it, right? So the negative would drop this down to here, but then because of the half, you're here. Does that make sense? So like if you should be graphing 0, that would stay the same. Your parent graph, when x is -1, y is -1, you would flip that because of the negative in the equation, and then you have to divide by 2, so you're here. So it's a 2-step transformation. Domain and range, I don't think should change. And then we said vertically shrink and a factor of 1/2. Domain and range, all real numbers. So why don't you go ahead and hit pause, try to do these two. So here's a third order. Again, remember what the parent graph looks like, and then double it, right? This is a vertical stretch. You're going to pull the y values up. And then notice here, this is the square root. So think of the parent graph again, and then let's flip it, and let's vertically stretch it. Hit pause, and when you're ready, hit play. I'm going to take a drink of tea. And there are your answers. So here we go. The 2, hopefully the parent graph you would have gone here, right? And then again, we don't see the 8,2, but it's out there. And when x was -1, you should have been here. So the parent graph would have had these 3 points. But because of the 2, you want to double it. And because of the 2, you want to double it here. And that's where we get our graph. So the parent graph for the square root of x would have been at 0. It would have been at 1, 1. It would have been at 4, 2. And now you've got to flip these and multiply by 2. So flip it would put at -1, multiply by 2, and you're at -2. And that's where the parent or the transformed graph is. And also notice that at 4, you would have been at 2, flip it, -2, double it, -4. Your domain and range do change, right? So your domain actually stays the same. Who did that? The domain stays the same. Sorry about that. And your range would be y less than equal to 0. I think I lost my pen. Hold on 1 second. Come back to me, pen. I got it. Pen's back. Let's go back to full screen. Sorry for the interruption. Hopefully you got those right. Again, powerful. You should be really excited, that you've learned this transformations for the absolute value and for parabolas, and it works. So here it comes. The whole kitchen sink is coming at you. So what do I mean? Well, what does the A do? Again, the A we just worked on. If it's a -A, we flip it. If A is 2, we vertically stretch it. If A is less than 1, like a half, we vertically shrink it. So what's the -h going to do? That's going to be a horizontal shift. So you're actually going to move all the points to the left or right. And then the K is your vertical shift. You're either going to shift everything up 1 or down, whatever. So add a number, you're going to move it up, subtract the number down. And guess what? The same thing applies for the third order. And again, you should feel awesome. If I had if I had written the equation for parabola here in vertex form, you'd say, I already did that. If I wrote it for the absolute value, I already did it. So it's really nice. Again, all the information here, H does the horizontal shift, K does the vertical shift. Let's try a problem. All right, so let's take a deep breath here. What are we graphing? This is the square root of x. And again, think back on the parent graph. And now we are going to shift everybody +1. Again, don't forget horizontal shift does opposite. We're going to move everything up 2, and we're going to stretch it. We're going to multiply everything by 3. And then they'd like you to state the domain and range. So here's the graph. So let's kind of break through this carefully. So as you can see here, the original parent graph, right, starts at the origin. And what they've done first is kind of taken the parent graph and amplified it by 3. So that, you would have gone over 1, up 1, but now you're up 3. Then they're including the shifting. So this point is going to shift +1, right, because this says x minus 1. Then you're going to shift this point up 2. So there's your starting point. Again, if this 3 wasn't there, your next point would be here, but we have to multiply that by 3. And again, if I had moved over 4 units, 1, 2, 3, 4, I would be here for the parent graph, but multiply by 3, and I should be boom, boom, right here at 6. These are tricky. We're going to practice these in class. Your new domain and range will change, right? So this is the graph, by the way. I know it's a bit confusing. This blue line is the graph that you should be done with. And you can see that it starts at x greater than 1. And you can see that the y values start at y greater than and equal to 2. And I should have said greater than or equal to 1 for x. So new domain and range. We will practice these in class. These are tricky. And good review, by the way, for our exam coming up. All right, so here we go. This guy, they're really, they gave everything. Why everything? Because of the negative. So we're going to flip the graph. We're going to multiply by 2. We're going to do a horizontal shift. This is going to shift at -3. And we're going to shift down -2. And again, because we're doing the third root, you need to think of the original parent graph. So here we go. This is how they're going to help us out. So here's your parent graph, right? And so the parent graph, again, this isn't the parent graph. This is the parent graph. They do it in steps, which I think is a wise move, right? They flipped it and put the -2. So they're here now, right? And this scale is at 2. So when you go to -1, you should be down at -1, but we flipped it and we multiplied by 2. And notice here, when you're at 1, you should have been here at +1, but we flip it to -1 and multiply by 2. And then they say, okay, take all these points and let's include the horizontal shift of -3 and the vertical shift of -2. And this is, let me trace it in blue, this is the graph sketched correctly. And again, if you're following along here and this is making sense, I'm super proud of you, because this has been a long path to get here. And it's good news, right? All the functions that we learned this year will follow the same pattern of shifting. Any issues with domain and range? No. And we really like the third, this always all real numbers, no matter how we shift it for third order polynomials. Hey, it's showtime for you. Let's see what you've got, right? This is going to be the square root of x with a negative, so we're going to flip it. It's going to shrink by 1/2. We're also going to do a horizontal shift of -3 and a vertical shift of +2. If you still got some oomph in you, try the third order, or excuse me, the cube root of x. And this does not have a horizontal shift, by the way. It does have a vertical shift of 2 and then a stretch of 3. And I hope I didn't give too much away. Go ahead and hit pause, and when you're ready, let's look at the answer. Well, how'd you do? Let's kind of look through how they did this, right? So again, your parent graph would have sat here, here, and here, right? This would have been the original parent graph. So it looks like we had to flip it. So this would have been the point, flip, but then also have it. And then over here, we should have shifted 4 up 2, flip the 2, we're down here. 1/2 of 2 is 1, and we would have been right at this point. So this is the general shape, and then we need to move these points, right, with the horizontal shift -3 and up 2. And this point would have moved -3 and up 2. Then this final point here would move -3 up 2. So again, not an easy problem, and you really should say, 4 separate pieces that go into graphing. This guy's a little easier because there's no negative and there's no horizontal shift. So your original parent graph was here, right? You should have moved over 1, up 1, but now we're moving over 1, up 3. And notice the scale, right? They kind of helping us out there. And then everybody gets shifted up 2. So you're here, right? Domain for this guy, you should say, hey, x has got to be greater than or equal to -3. And for the range is y is less than, right? Because this drops down less than 2. And we love, again, that the third root of x, all real numbers for domain and range. Hey, well done. If you made it this far, congratulations. We only have one more section, by the way, for this semester, and we're done. I'll see you tomorrow in class.